Hello viewers, welcome to video number 98 of the channel MALACHEMPHILIC, and video number 98 is the 39th episode of Chemical Thermodynamics, and topic of this episode is Entropy Changes in Reversible Noncyclic Processes Part 2. In part 1, I have discussed, that means in my previous video, I have discussed the entropy change in reversible process, entropy change in the reversible isothermal process of the ideal gas, and entropy change in the reversible adiabatic process. Now in today's video, I'll discuss the entropy change in the isochoric process for the ideal gas. That means where volume is constant, and also isobaric process where pressure is constant. So let's start. So the topic is entropy change in isochoric process of ideal gas. In my last video, I have derived this equation for reversible process, that is entropy change of the system is equal to NCV ln T2 by T1, where N is number of moles, CV is the molar heat capacity at constant volume, T2 final temperature, T1 initial temperature, plus NR ln V2 by V1. R is universal gas constant, V2 final volume, V1 initial volume. Now, for isochoric process, delta V is equal to 0, or what we can write, V1 is equal to V2. So, in that case, delta S system, which is equal to NCV ln T2 by T1 plus NR ln V2 by V1, this part is getting cancelled. So, delta S system, that is equal to NCV ln T2 by T1. Now, let's see the entropy change in the surroundings. Okay. See, entropy change in the surroundings, delta S surroundings, that will be equal to minus, we can write, Q reversible of system. If I write in terms of system, Q reversible heat is absorbed by system, that means surrounding has released this much. So minus Q reversible of system divided by this temperature. Okay. Achha. Now see, we know that ds is equal to entropy change, ds is equal to del Q reversible by T. So, TDS is equal to del Q, and del Q means small amount of heat absorbed, del Q reversible. Okay. So, this entropy change of the surroundings, that is ds, if I write in terms of small change, ds surrounding, that will be equal to ds of surrounding, that is equal to my del Q reversible by T which is equal to minus means I write in terms of system. Okay, later I write. So which is equal to TdS by T, and TdS is equal to, this is your minus del Q reversible in terms of system by T. Okay, so del Q reversible minus del Q reversible system by T, that means that is the entropy change of the surroundings. So overall I can write entropy change of the surrounding, that is equal to minus, from here minus Q, already I have written here, minus Q reversible by T of system. Okay, and that is equal to, what is Q reversible by T, that means entropy change of system, NCV ln T2 by T1. So it will be minus NCV ln T2 by T1. So delta S total or delta S universe, that will be equal to delta S system plus delta S surroundings, that is equal to, delta S system is NCV ln T2 by T1, delta S surrounding is minus NCV ln T2 by T1, and that is equal to 0. So total entropy change of the system and surrounding is 0. Okay, so first from this equation I have determined entropy change of the system. Now surrounding entropy change will be this one. Then from this equation we have written this one. Then surrounding entropy change, once again that will come. This is just for your information, and then minus CV ln T2 by T1. So this is 0. Look at here entropy change of the system is not 0. Surrounding is not 0, but overall entropy change of system and surrounding is 0. Next one is your entropy change in isobaric process. Isobaric means pressure constant, that means delta P is equal to 0. Okay, now once again we'll write that, what we can write from first law of thermodynamics, from first law of thermodynamics, what we can write, that is your del Q reversible is equal to del D plus PdV, and that is equal to dH, change of enthalpy, where enthalpy H is equal to E plus PV. Okay, so delta S of the, or change in entropy of the system, that will be equal to your del Q reversible by T, and that is equal to, I can write dH by T, right? Now we know that dol H by dol T at constant pressure, that is equal to Cp, heat capacity or molar heat capacity at constant pressure. So therefore dH is equal to Cp dt, that is for 1 mole, and dH is equal to Ncp dt, that is for n moles, right? So DS system, change of entropy, small change of entropy of system, which is equal to dH by T, that is equal to Ncp dt, right, divided by T. Okay. So overall entropy change of this system, delta S system, that will be equal to your integration of Ncp dt by T. Okay. So this N is number of moles, that is constant, I can take outside of integration sign. Cp, molar heat capacity at constant pressure, assuming that that remains constant within the temperature range, say T1 to T2. So it is dt by T, T1 to T2. So delta S system, that will be equal to Ncp ln T2 by T1. Hope you have understood this one, because integration of 1 by T dt, that is ln log T, log base E, that is ln T upper limit minus lower limit, that means ln T2 minus ln T1, so ln T2 by T1. So this is the entropy change of the system. In the isobaric process, I have derived this one. Now coming to the entropy change of the surroundings. See, entropy change of the surroundings. Okay, so that I can write delta S surroundings, that will be equal to, delta S surroundings will be equal to minus, that is Q reversible of the system divided by T. Okay. Now Q reversible by T system means entropy change of the system. This part is entropy change of the system. Here I am writing, that is Q reversible by T, that is the delta S system. Okay. So this is delta S system. So delta S surroundings, that will be equal to minus delta S system. So it is minus Ncp ln T2 by T1, right? So therefore this total entropy change in the isobaric process, that is entropy change of the universe, which is entropy change of the system plus entropy change of the surroundings, that is equal to, system is Ncp ln T2 by T1 minus surrounding is Ncp ln T2 by T1, that is equal to 0. So entropy change in the reversible process is 0. Okay. Entropy change of the system in isobaric process is NCP ln T2 by T1. Surroundings also will be same, only the negative sign. So these are the entropy changes in isochoric and isobaric process. Next video I will discuss about the entropy changes in irreversible process. So we have come to the end. Thank you.